Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So this is a problem from audience, and I would like to put it into the geometry chair as well because this is a problem related to the Incenter property. So I also call it Incenter property supplementary. It's called Sparrow Lemma. The problem is this: let I be the incenter of triangle ABC. So we have a triangle here. Let's call it ABC. Point U lies on ray AB and point V lies on ray CA beyond A. So this is U, this is V. So that AU minus AV equals to AB plus AC minus BC. Right, so it satisfies, the U and V satisfy some equation here. Then points AI, UV are cyclic. I is the incenter here, right? So we want to prove that UI, AV these 4 points are cyclic. This is another problem. Could be a very good example to my points that for the problem that you don't know how to add auxiliary line, think about how to draw the figure, use ruler and compass only. So the first thing we do here is that we have to manipulate with this equation to simplify it. We know that AU and AB are on the same ray. AC and AV are on the same ray. So we put them together, then we have AU minus AB equals to AV plus AC minus BC, which means UB equals to AV plus AC, that is CV minus BC, which means UB plus BC equals to CV, right? UB plus BC equals to CV. It's good enough to give us a hint how to draw the figure, right? So if I draw the figure, I would like to start with a point C here, because we already know that UB plus BC equals to CV. So I can think to start drawing, use C as a center. Right, use C as a center and choose arbitrary radius. So this point, let's call it V. This point, let's call it T, right? We have CT equals to CV. Then we connect VT. Then we can arbitrarily choose 2 points on the CV and CT respectively. Let's call it A and B. We connect AB and we extend AB. We extend AB to a point that BU equals to BT, right? In this case, we know that BU plus BC equals to BT plus BC equals to CT equals to CV. So we satisfy that BU plus BC equals to CV, right? Now we connect UT, we connect, we find the incenter of the triangle ABC here. So roughly say, look like this, okay? This is I. Now the problem is that how can we prove IAVU are cyclic, right? So we connect UI here, we connect UV here. And because we already have the AU, so I also connect VI. So for the 4 points like cyclic quadrilateral, we have many methods to prove. Here we just need to choose a smart one. Next thing is that think about the figure. We already have the properties that CT equals to CV, and CI is the angle bisector of angle VCT. This is important because based on this, we know that if I connect IT, if I connect IT, we know that CT equals to CV, CI equals to CI, and angle ICT equals to angle ICV. So the triangle CIV is congruent to triangle CIT, right? So we get the conclusion that IV equals to IT. Triangle CIV is congruent to triangle CIT. So we know that IV equals to IT. Similarly, for here, if we look at this figure, because angle ABC equals to angle TBU, right? So BI is the angle bisector of angle ABC, then it's the angle bisector of angle TBU. Then we can just connect it down here. So if I redraw this part here, make it easier to understand. We have T here, we have U here, and we have a point B here. Then we know that BT equals to BU. It's BT equals to BU. It's an isosceles triangle, and we have the angle bisector here, which is an angle bisector here. As we already know, it's an isosceles triangle, so we know that this is 90 degrees, right? Then we know that this line, it's not only the angle bisector of angle TBU, it's also the perpendicular bisector of segment TU, which means any point on this line, on the line BI, has an equal distance to T and U, which means we get IT equals to IU. This is important. So we have IT equals to IU equals to IV, right? Which means I would be the circumcenter of the triangle VTU. Okay, so look at what we have here. We already know that triangle ITC is congruent to triangle IVC, which means this angle equals to this angle, right? And we know that B and I are on the angle bisector of B and I are on the perpendicular bisector of the segment TU. So we know that this angle, the angle BTI equals to angle BUI. Right? Many methods we can prove this, right? We can just prove that the triangle IBU is congruent to triangle IBT. Right? Very easy to prove that. So we know that this angle equals to this angle, which means the angle IUB or IUA equals to angle IVA. Right? The angle IUA equals to angle IVA. That means IAVU are cyclic. Okay, so for this problem, or for this property, I feel it's very interesting property. I think to write the equation like this is just to make it looks like more complex, right? It relates to the AB, AC, and BC, but actually you can simplify it, and then we get this conclusion based on the several auxiliary lines, and those auxiliary lines are added based on how to draw the figure. Okay, that's it. I hope you like this video. See you in next one. Thank you.